All right, so today we move on here. Here's our problem of the day. It's a multiple choice word problem dealing with rate of change. Pause the video, write out your work, and choose the correct answer. Now today we deal with lesson 2.3, graphs of equations and lines. And there's two kinds of forms that we're going to look at graphing today, which I'm pretty sure you're familiar with both, but we're going over them. The first form is slope-intercept form. It's the equation y equals mx plus b. And I think it's pretty much the most common way we ever graph in y equals form. So there's 4 steps to use in slope-intercept form to graph an equation. Let's go through each of these. Step 1, write the equation in slope-intercept form by solving for y, if it's not already in y equals. 2, identify the y-intercept, the b, and use it to plot the point along the y-axis. You're going to move up or down. Up if it's a positive y-intercept, down if it's a negative. Step 3, identify the slope m and use it to plot 2 more points on the line. So our direction will either go up or down, then left or right. Up if it's a positive, down if it's a negative, and then left for negative, right for positive. Now you could do more than 2 points. Really a line you only need 1, but conventionally I think it's easier if we do 3. Give a little bit more of the line, all right? Finally, after you have all your points, draw a line through the points. All right. So let's take a look at these examples. And if you need to write any of the steps down, please feel free to do it as I talk through them. Since this is a review, I'm not going to write down steps 1 through 4. So if you have questions, or pause the video, ask me tomorrow, okay? So my y-intercept, this is my b, it's -2. All right. Maybe, well, actually, okay, let me write what each of them are. So b is -2. So what that means is it's either up or down. If you look back to your steps, in case you forget, positive b is up, negative b is down. So -2 means down 2, we plot our point. Okay. Then my slope is the second one I'm going to graph. M equals 3/4. And just as a little note for at least this one, that means the top number I move up or down. Because remember, it's change in y over change in x. So if y is on top, you move up or down, right, for the y-axis. So we're going to go up 3. Then we're going to go left or right for the denominator. It's a +4, so we're going to go right 4. Okay, so here we go again. I go to my y-intercept, my b. From that point, I move up 1, 2, 3, right 1, 2, 3, 4, plot my point. And I'm going to do it one more time. Now you could go in the same direction. You could go down. I don't care either way. You could go up 3, right 4 again. Sometimes I like to go back. I like my line to cut through all the axes, so I like to go back to the original point and do the opposite. So if I went up 3, right 4, I would go down 3, left 1, 2, 3, 4. All right, does that make sense? So left 3, or excuse me, down 3, left 4, because we're doing the opposite. And then the last step, see how I am, my mouse here. Connect your points. All right. Now in B, my problem's y equals -2x. And you're going to notice I'm missing the b or the y-intercept. Think about what that should be. It should be 0, because there's nothing here. So if it's 0, I'm not going to move up or down. 0 is just 0, so my y-intercept is 0 and it's here, right at the origin. My next is slope, which is -2. But remember, we're moving up or down, then left or right, so we need a fraction. So I'm going to put it -2 over 1. So that means I'm going to go down 2, right 1 each time. So from here, down 2, right 1, plot the point, down 2, right 1. Or we could go back to the origin, go up 2, left 1. All right. and connect our dots and make our line. So I added a fourth point there just to show you. Sometimes I go in the same direction. It really depends on where my y-intercept is and how much room I have to go in that direction. If I tend to go off the graph, I'll move back to the original point and move in the opposite direction. All right? Now, what if we have horizontal or vertical lines? Because I know we had one like that in assignment 1. So let's talk about that for a minute. If it's a horizontal line, it's y equals. If it's vertical, it's x equals. C stands for whatever number it is. So example 3, graph the horizontal and vertical lines on the graph below. Y equals -3. Here's how I remember it. First, you start by finding where -3 is on the y-axis. So -3 would be what, down 3? Right here. Okay. Now I have two choices. Either it's a vertical line or horizontal line. You might see from the notes which one it is. But here's how I remember it. If I draw an up and down line, it cuts right through the y-axis. It will be the y-axis. It's always the opposite. If you look above, the notes actually say y equals is the horizontal line. So it's y equals -3 as in C. Like that would be the C, right? It's a horizontal line. Now vertical, x equals 4. Start by plotting point at 4. Okay. And this one's the vertical, it's the opposite here. So draw your line. All right. So we took a look at graphing and y-intercept. We're looking at vertical and horizontal because they're sort of in their own little category. The next one we're going to take a look at standard form. Now standard form, we don't really use that often. I'll be honest, in math, I don't use it. But sometimes standard form, especially with word problems or bigger numbers, it actually makes more sense to use it that way. And actually, it's easier sometimes than we think. So standard form is ax plus by equals c, so the x and y are on the left. And here's our steps to using standard form to graph an equation. Let's start with 1. Identify the x-intercept by letting y equals 0 and solving for x. Use the x-intercept to plot the point along the x-axis. It's a single point on the axis. Well, if we do that for x, gotta do the same for y. Go back to the original. Identify the y-intercept by letting x equals 0, solving for y. Use the y-intercept to plot the point along the y-axis. Finally, draw a line through the 2 points. So in this method, you're only doing 2 points, one on each axis and connecting them. Now I said we take it for granted. We don't really use this method that much, but sometimes it comes in handy. You know, if it's in standard form, it might not be bad to keep it that way and plug the points in. Why rearrange the equation to get y equals when it's not that difficult of a method? So let's take a look at our examples here. All right, we're going to graph them. I have -2x minus 3y equals 6. So my first step tells me, identify the x-intercept by letting y equals 0. So I'm going to rewrite this, plugging 0 in for the equation and solving for x. So what do I get? -2x, this goes away, equals 6. And when I divide by -2, I get x equals -3. That's it. All right, so you plug in 0 for y. So I get x equals -3. So along the x-axis, find -1, 2, 3. Plot your point. Now, it's a single point. Plot it on the x-axis. All right, I'll talk about a common mistake people make as we go when we get to it. So it's pretty easy. I mean, you're plugging 0 and getting rid of a variable. It's not that much algebra involved. Sometimes we think it's worse than it is. So now we got to do the same thing for the y. We're going to solve for y by plugging in 0 for x. So let's try this again. Plug in 0, get -3y equals 6. And I divide by -3, get -2. So y equals -2. Now where is that at? I go along the y-axis, it's negative, so it's down 2. Plot my point. And that's it. Connect your points. Now before I connect them, I see a very, very common mistake. This is not an ordered pair. It is not x comma y. Because I'll get people that plot that point, which would be what, here? And then they have a point. It's not a line. Make sure, if you get in the habit of graphing one at a time, like solving one and then graphing the point, I think we won't have that problem. But here's my answer. Connect the dots, you only have 2 of them here. You probably don't even really need to show a lot of work for these when you're solving them. Okay, and it might not be a bad idea. You might want to pause the video and try be yourself. All right, so I'm going to do that one next. So let's solve for x first. We're plugging in 0 for y. So I get x equals 2. Positive 2 is here. And then we have to solve for y by plugging in 0 for x. And get y to equal 5. It's positive 1, 2, 3, 4, 5. And then let's connect them. And that's our graph. All right, that's it for today. Let's take a look at your problems to review. Number 1, problem of the day, just like every other day. And then we only have a second problem. I mean, there's 6 graphs, but I want you to graph all the different ones that I have there for you. And we'll continue tomorrow with going over the problems. That's it for today.